Section 1. The unseen ingredient. Hydrogen's quiet role in our kitchens. We often think about the ingredients we can see and taste. We check labels for sugar, salt, fat. We worry about where our food comes from and how it was grown. But there is a hidden element at play in our food system. It is an ingredient you will not find listed on any package, yet it shapes the food we eat every day. This element is hydrogen. It is the most common substance in the universe, and its role in how our food is produced, processed, preserved is growing. This simple gas is an unsung hero working behind the scenes. The food industry faces significant challenges. One of the biggest is food waste. A large portion of the food produced globally never makes it to our plates. It spoils during transport or on store shelves. Another major issue is the environmental impact of food production. Section 2. From liquid to solid. The magic of hydrogenation. One of the oldest and most familiar uses of hydrogen in the food industry is called hydrogenation, a form of food chemistry many of us have eaten without even knowing it. The process takes liquid vegetable oils and turns them into solid or semi-solid fats. Soybean oil, canola oil side by side, liquid oil beaker and block of shortening. Food manufacturers do this by bubbling hydrogen gas through heated oil. Close up, bubbles rising in a heated beaker of oil. A metal, typically nickel, acts as a catalyst to speed up the reaction. Close-up, nickel catalyst pellets, or bed. Adding hydrogen atoms changes the molecular structure of the oil. That makes the oil more solid at room temperature. This transformation is incredibly useful for food makers. Hydrogenated fats have a longer shelf life than liquid oils. Liquid oils can go rancid quickly. Spoilage comparison. This stability is crucial for products that need to last, such as crackers, cookies, packaged baked goods. The process also lets producers control texture and melting point. Section 3. Feeding the world. Hydrogen's link to fertilizers. Beyond the factory, hydrogen plays an even more fundamental role in our food system. It helps grow the food in the first place. The connection is through the production of ammonia, which is the primary component of most modern nitrogen fertilizers. These fertilizers are responsible for a huge portion of the world's food supply. Without them, crop yields would plummet, and feeding a global population of billions would be nearly impossible. The process that creates this essential ammonia is called the Haber-Bosch process, and hydrogen is its most critical ingredient. Developed over a century ago, it combines hydrogen gas with nitrogen from the air. This reaction happens under extremely high pressure and temperature. The result is liquid ammonia. This invention has been called one of the most important of the 20th century because it allowed us to produce fertilizer on a massive industrial scale. This ability to enrich the soil with nitrogen has dramatically increased the productivity of farms worldwide. Every time you eat a piece of bread, one of the biggest enemies of fresh food is oxygen. When food is exposed to the air, oxygen causes it to spoil. It can make fats go rancid, cause fruits and vegetables to brown, and change the flavor of packaged snacks. To combat this, food companies have developed a technique called modified atmosphere packaging. This involves removing the oxygen from a food package and replacing it with a different gas or a mix of gases to extend the product's shelf life. Nitrogen carbon dioxide. However, hydrogen also plays a small but important role in this area. Even after most of the oxygen has been flushed out of a package, tiny trace amounts can remain. For very sensitive products, nuts, coffee, powdered milk, even this small amount of oxygen can cause spoilage over time. To solve this, some packaging systems include a tiny packet containing a catalyst. A small controlled amount of hydrogen is also added to the gas mixture inside the package. The catalyst helps the hydrogen react with any leftover oxygen, turning it into harmless water vapor. This process, known as deoxygenation, effectively scrubs the last bits of damaging oxygen from the package. Hydrogen's influence extends deep into the world of food ingredients. It is used as a tool to create and modify molecules. This is especially true in the production of certain sweeteners. Many people are familiar with sugar-free products, chewing gum, diet sodas. Some sweeteners are made through a process that involves hydrogen. These are called sugar alcohols, polyols. They sweeten with fewer calories and don't cause tooth decay. A common example, sorbitol starts as glucose, a simple sugar, then, via hydrogenation. Hydrogen is added, and glucose becomes sorbitol. Same principle for other sugar alcohols, mannitol, xylitol. They taste sweet, but aren't absorbed like sugar. Hydrogen lets food scientists make many low-calorie, sugar-free options for people managing sugar intake. Hydrogen use isn't limited to sweeteners, it's also used to make other food additives. For example, hydrogenation can improve the stability of certain vitamins, keeping them effective through a product's shelf life. The food processing industry is an energy-intensive business. Factories rely on a constant supply of heat for baking, drying, sterilizing, pasteurizing ovens, boilers. Fryers are often powered by burning natural gas, which releases carbon dioxide. Companies face pressure to reduce environmental impact and are looking for cleaner energy sources. Hydrogen is emerging as a promising alternative. When hydrogen is burned, the only byproduct is water vapor. It can provide the intense heat needed without producing carbon emissions. Several food and beverage companies are experimenting with this technology. Pilot projects are replacing natural gas burners with hydrogen-powered ones in boilers. The transition requires new infrastructure, redesigned burners, robust safety protocols. A widespread switch to green hydrogen could dramatically decarbonize food manufacturing. It would let factories produce the same foods with a much smaller carbon footprint. Throughout this deep dive, we have seen the many hidden ways hydrogen supports our food system. It transforms oils into stable fats. It helps grow crops through fertilizer. It keeps packaged goods fresh. It creates essential ingredients like sweeteners. It also offers a path to cleaner energy for factories. And it's a key component in the sanitizers that keep our food safe. The benefits are clear. Hydrogen helps improve food quality. It can extend shelf life. And it can significantly reduce the environmental impact of food production. It's a simple element with a powerful and diverse set of applications. However, the path to a fully hydrogen-powered food system is not without its challenges. The biggest obstacle, right now, is cost. Producing green hydrogen from renewable electricity is still more expensive than creating it from natural gas. The food industry operates on tight margins. Companies are often hesitant to adopt new, costly technologies. A widespread shift to hydrogen would require significant investment in new infrastructure, production plants, pipelines, storage facilities. These are major hurdles that will take time and coordinated effort to overcome. Safety is another important consideration. Hydrogen is a highly flammable gas that must be handled with care. While industries have been using hydrogen safely for decades, expanding its use into more areas of the food system will require strict regulations. It will also need robust safety protocols and proper training for workers. Building public trust and addressing any concerns about safety will be just as important as developing the technology itself. Honesty and transparency about both the risks and the rewards will be essential as we move forward. Despite these challenges, the future looks promising. As the cost of renewable energy continues to fall, green hydrogen will become more affordable. Governments and industries are investing in research and development to improve hydrogen technologies and to build out the necessary infrastructure. The payoff is a food system that is more resilient, more sustainable, and less dependent on fossil fuels. Hydrogen is not a magic bullet, but it is a vital tool. With continued innovation and careful planning, it can play a central role in building a cleaner, safer, and healthier food future for everyone. From the farm to the factory, the process of making food generates greenhouse gases. These emissions contribute to climate change. As the world looks for cleaner, more efficient ways to operate, the food industry is turning to innovative solutions. Hydrogen is emerging as one of those key solutions, offering a path to better food and a healthier planet. This chapter will take a deep dive into how hydrogen is used in the food we consume. We'll explore traditional roles like the making of margarine. We'll also look at its vital contribution to fertilizers that help crops grow. The journey does not stop there. Hydrogen helps keep food fresh, creates sugar-free sweeteners, and can power factories and trucks.